Hello students, today we'll discuss IB Math SL Paper 1, November 2018. In this paper you cannot use calculator. My name is Nariman Melim. Here you can see my mobile and email. The main sources for exam will be textbook from Oxford 2012, guide Mathematics SL Guide First Examination 2014, and you should be very well aware about the information inside data booklet because it contains formulas. So Mathematics SL formula booklet. This is the cover page. The exam is for 1.5 hours. Let's start. Section A. Question 1. The following diagram shows a circle with center A and radius 6 centimeters. The point BCD lie on the circle and BAC is 2 radians. A. Find the area of shaded sector. Question 1A. I will give reference to data booklet. So data booklet section 3.1. Area of a sector is given by this formula where theta is angle in radians and r is radius. So we put values and we get 36 centimeters squared. Find the perimeter of non-shaded sector. Be attentive, non-shaded sector. So it is in here. So angle subtended is 2 pi minus 2. Again we use data booklet. Perimeter will be AB plus AC plus arc. So data booklet gives us the length of an arc. It is radius multiplied by angle in radians. So it is 2 pi minus 2. So we get 2 pi r minus 2r. Perimeter will be radius plus 2 pi r minus 2r. 2r simplifies. We get 2 pi r, which is 12 pi centimeters. Question 2. Two functions f and g are defined in the following table. Write down the value of f1. So f when x is 1, it is 3. Find the value of g f1. So first f acts and then result goes to function g. So f of 1 is 3. So 3 goes to as argument of g. So g of 3 is 5. So answer is 5. Find the value of inverse function to g for minus 2. So inverse function is x and y are swapped. So it means that we should find when y equals minus 2 how much is x. So x is 1. So here we have 3 answers. Question 3. In an arithmetic sequence, u1 equals minus 5 and d equals 3. Find u8. So booklet, so u1 minus 5, d equals 3, u8 question mark. Booklet 1, section 1.1, nth term of an arithmetic sequence is given by this formula. We substitute n 8, n minus 1, 8 minus 1, and we get 16. Find the value of n for which un equals 67. So un equals 67. We use the same formula. Now unknown is n, but known is un. So we get 25. Question 4. Let b logarithm a of 2 where a more than 0. Write down each of the following expression is termed as b. So a. In a we use laws of logarithm. So it is power goes, or exponent goes out of logarithm, we get 3b. logarithm 28a. Again, laws of logarithms. Here product, it turns into sum, we get 3 plus b. Logarithm 8 of base for base 8, we use 1 to change of base from 8 to 2. So we change base. This is why 8 to base 2 divided by 8 to base 2. 8 to base 2 is 3. So, and this is b. So b over 3. Done. Question 5. Consider the vectors. Find the possible values for p for which a and b are parallel. So if a and b are parallel, then a equals kp. So for example, k is multiplied by x coordinate, k is multiplied by y coordinate, and as a result the ratio of x coordinates and y coordinates will be equal. So ratio of x coordinate is 3 over pi plus 1 equals ratio of y coordinates 2 pi p over 8, which equals to k. We don't care about k. How to solve it? We cross multiply. We get 3 times 8, 24, 2 pi plus 1. We simplify by 2, and then we can factorize very easily, and so split p into minus 4 plus 3 and get 2 solutions. Or use standard formula 2-7 solution of quadratic equation, taking into account that a is 1, b is 1, and c is minus 12. So we will get the same answer. Question 6. So we have functions. The following diagram shows part of the function. The region R is enclosed by the graph, the x-axis and y-axis. Find the value of R. So area equals definite integral from x equals 0 to x equals intercept. Intercept means x-intercept when y equals 0. So it is upper limit of our future integral. So fx equals 0. We find that this happens at x equals 3. Now here, to find indefinite integral, you can use, for example, expression under the square root, but then you should use a next method. The easiest way is replace x by the following. So let's take new variable u to be square root of what is under the fraction bar. Then du by dx will be 1 over 2 minus 1. So half minus 1 equals minus over 2. 6 minus 2, right. So actually we get 2 du equals our expression. So our expression, integral of our expression equals 2 du or 2u. Now to find definite integral, we should find difference of values at 3 and 0. We substitute 3 and we substitute 0 and subtract them. We get 2. Question 7. Given that sine equals 1 over 3, find the value of cosine. Here we will use section 3.3, double angle identity, twice. So first time it is double angle, so it will be 2 cosine squared 2x minus 1. Now cosine 2x we will change in a bit different expression, 1 minus 2 sine squared, and here I forgot squared, so I will put here squared. Right, then we put, instead of value sine, 1 over 3 squared 1 over 9, and and if you do very accurately, work with fractions, so 1 minus 2 over 9 give us 7 over 9, 7 over 9 squared give us 4981, multiplied by 2 give us 9881, minus 1 give us 1781. Done. Section B. So we have functions. The following diagram, this is a quadratic parabola, this is parabola. Find x-intercept of the graph. So we need to do the solutions a bit aside. So here we have solution. Find x-intercept of the graph of y. So x-intercept means function equals 0. So function is x squared minus 4x minus 5 equals 0. Again, we can factorize easily or use quadratic formula for a equals 1, b equals minus 4, and c equals minus 5. Answers here is minus 1 and 5. Question B. Find the equation of the axis of symmetry of the graph of H. So again, in the booklet we have 2, 4, axis of symmetry of quadratic function given by x equals minus b over 2a, so minus 4 over 2, minus minus give us 2, so it is at x equals 2. Next question. The function, let's make it clear that we have, okay. The function can be written in the form like this. Write down the value of h, write down the value of k. So I have drawn here a parabola, and we know that this is the position of the vertex, and the vertex give us these values h and k. So h and k are coordinates of vertex. H we already know, it is 2, and k we should calculate. So when f equals h, how much is the value? So h equals 2, coordinate of minimum of axis of symmetry equals minus 9. So the value at this point is minus 9. So we should say that k equals minus 9. This is our answer. The graph of the second function is obtained by a reflection of the graph in the y-axis followed by translation. So, reflection of the graph in the y-axis, and what they want, find the coordinate of vertex. So what will happen to the vertex if we have reflection over y-axis? X will be inverse, multiplied by minus 1, and y will not change. So we get point minus 2, minus 9. So x will be minus 2, y will be minus 9. Then, to have translation, we should add this vector of translation, minus, so we look here, minus 2 minus 9 is after reflection position of vertex, plus the vector at which we should translate. We get minus 2 minus 3 minus 5, minus 9, 6, minus 3. So done. This question is done. Question 9. A bag contains n marbles, 2 of which are blue. Haley plays a game in which she randomly draws marbles out of the bag, one after another without replacement. The game ends when Haley draws a blue marble. Find the probability in terms of n that the game will end on her first draw. Let's look. So we have 2 blue, n minus 2 white, and total is n. So probability that the first is blue is successful outcomes, which is 2 by total number of outcomes, which is n. So it is 2 over n. First draw. The first draw, second draw. The second draw means that the first is white and the second is blue. So we have product of this event. So the first white is n minus 2 over n, and the second blue is 2 over what is left, n minus 1. Simplified, it looks this way. Let n equals 5. Find the probability that the game will end on her third draw, fourth draw. So n equals 5. Third draw, it means that probability of first is white times second is white and third is blue. So we use the same method. So first probability of white out of n minus 2 is white. Now next again white, but this time we have only n minus 1 marbles and n minus 3 of them are white, and finally we have n minus 2 marbles, 2 of which are white. So we put the values and we get 1 over 5. The same we do for fourth. So white, 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 and probability of blue. Haley plays a game when n equals 5. She pays $20 to play and can earn money back depending on the number of draws it takes to obtain a blue marble. She earns no money back if she contains a blue marble on her first draw. Let m be the amount of money she earns back playing the game. This information is shown in the table. Find the value of k so that this is a fair game. Fair game means that expected value of balance should be 0. So 5, 7, expected value of discrete random variable, so expected winning. So expected winning will be value of winning by probability. So when marble is 1, 2, 3, and 4. But expected value of balance will be the value of balance. So here minus 12, here 0, here minus 20, here minus 20. And it should be equal to 0. So we have equation for 1k, and k will be 5. Done. So now question 10. So we have cubic function, part of function f, and the graph f crosses y-axis as point P, so this is y-intercept. The line L is tangent of the to the graph of f at P. Find the coordinate of P. So to find coordinate of P, we should find y-intercept, so x equals 0, how much is y? So when x equals 0, y is 6. So point is 0, 6. So we found coordinate of point P. Find derivative of function. Derivative of function, so derivative will be 3 squared minus 2 times 2x minus 4x plus a. Here I gave you. Hence find the equation of line in terms of a. Equation of line will look this way. M will be tangent to the graph at point 0, and tangent equals derivative. So derivative is a at point 0. We take point 0, 6, so x1, y1, substitute here, and we get the expression for the line. The graph of f has a local minimum at point Q. The line L passes through Q. Find the value of A. So we have actually three conditions. Two conditions. Line L, which is tangent, intersect with function, one condition, and second, Q is minimum. Using these two conditions, we should find A. First condition, two lines, tangent and function, intersect at Q. It means that y equals ax plus 6 and y equals our function. So we simplify, we get x equals 2. We don't take x equals 0 because we know that it is not minimum, it is inflection. Right, now minimum at Q means f prime if derivative equals 0. So derivative equals 0 at this point. We already know the coordinate of this point. X equals 2, so we put coordinate of this point and we get A equals -4. Paper is over. Thank you for your attention. See you next time.